Alright, so this video is going to demonstrate and go through these examples here of recognizing the difference of two squares. Okay, so normally we see a difference problem and we see both terms are perfect squares or at least even exponents or something of the like, and then we can break it down into its factors. So n plus 9 and minus 9 would be an example. But now I want to go backwards. I wanted to know what the original expression was before it became factored. So when I take a look at this, n plus 9 and minus 9, notice how the n is the same. So n is the same, n is the same. 9 is the same, 9 is the same. That's the key. So you first have to recognize it's the same exact terms in both parentheses. And then, of course, the crucial part is one of them is plus, one of them is minus. So they have to be opposite signs. So once you recognize that, what you can do, normally you'd say, oh, well, can't you just multiply, find each product, so multiply that, multiply that. You can totally do that, but remember, in pre-calculus is all about saving time. We want to make sure we take whatever steps we can in order to save some time. So we're preparing ourselves for calculus, which again, you have the calculus work, and you don't want to be stuck doing the rudimentary algebra in the process. So again, if you were to multiply this out, it would be n squared minus 9n plus 9n minus 81. So rather than having to multiply all that out and say, oh, negative 9n plus 9n, those cancel out, my answer is n squared minus 81, we can just simply go to the final answer from the two parentheses. So again, how you do that is you recognize n in both, 9 in both, and the signs are different. If that's true, just square the first term, square the last term, 81, and then just put subtraction below it, and we get the same answer. So let's do number 2 here to make sure this shortcut holds through. So again, 6x, 6, 6, perfect. 1 is plus, 1 is minus. That means I can go straight to squaring the first term, so that'd be 6 squared x squared, which is 36x squared. Squaring the last term, so 6 squared is 36. And then putting subtraction in between them. So 36x squared minus 36. Again, if we were to do it the long way, let's go ahead and show you that. So if we were to distribute the 6x and then the 6, I would get 36x squared minus 36x plus 36x minus 36. Notice how minus 36x plus 36x cancel out, and again, that would be my final answer. Okay? So that not only works with simple binomials like that, but 2x plus 7y will work. Again, notice I have 2x in both parentheses. I have 7y in both parentheses. Opposite signs, perfect. That means I can go straight to this, so 2 squared x squared, which is 4x squared. 7 squared y squared, which is 49y squared. And put subtraction between them. So it doesn't matter if there's a second variable or something weird in either of the terms. Remember, the procedure is still the same. Nothing changes. So for number 4, again, if you want to challenge yourself, go ahead and pause the video and see if you get it right. But I'll go ahead and explain it here. So 7x, 7x, 3y, 3y. Signs are different. Perfect. So I can just go straight to 7 squared x squared, which is 49x squared. And then 3 squared y squared is 9y squared, and subtraction in between them. Okay? So that's how you do the reverse difference of squares.